So today our special guest is Professor Tomasz Górecki, who is a professor at the Department of Mathematical Statistics and Data Analysis at the Faculty of Mathematics and Computer Science of Adam Mickiewicz University. It is our co-organizing faculty together with the Faculty of Law and Administration. His main research, Professor Górecki, includes methods of artificial intelligence, so AI, machine learning, and time series analysis and their applications. He's an author of over 80 scientific papers, 3 books. He's an R programmer. He's also programming in Python, so maybe he can also share his views on what's better to learn, R or Python, because that's one of the questions that is coming back all the time. And he has more than 15 years of experience in programming. He's a great data scientist. He's also supervisor of our programming team, so he's supervising Jędrzej. So you can imagine how good is Professor Tomasz Górecki in programming, because actually Jędrzej Wydra, who was mostly in contact with Professor Górecki, is our, teaching everyone, and he's like everyone can see his knowledge. So Professor Tomasz Górecki will introduce us to the topic of how to work with maps in our studio, which might be particularly useful if you would like to investigate some areas of electoral law, law enforcement, things like this. So, dear Professor, the floor is yours.
Okay, thank you very much for this introduction and welcome everybody. As you said, today I'll try to show you how to use R and RStudio to present data on maps. So we try to use different libraries. I have quite huge file in R. I prepared R Markdown. Maybe I try to share my screen. Okay. Oh, I hope that you see everything. I try to. Okay, now. Okay, so how we can prepare maps in R? Of course, we have a lot of different libraries to do this. For main maps today, we try to use ggplot. I hope that you have some background with this because this is the main graphics library in R in general. So I didn't want to introduce different libraries, graphical libraries. And of course, we need additional libraries which help us to prepare data for spatial format. Also, we try to use Google Maps. So we try to plot maps using Google interface and add additional information like points, lines to the map prepared by Google. Okay, I think that we can start. First, I try to load a lot of libraries. Okay, so for each library, maybe in a few words, ggplot, it's a main graphics library. To manipulate data, we will use DPYR libraries. It's very popular library to manipulate data. And in this workshop, I show you only a little using of it. For spatial data maps, we have in this library, we have shapes of countries. We would like to also add arrow and scale to the maps of USA, which are very popular maps. Google API. This is library to add text to the map, not only to the map, but in general to the plot in much more flexible way. Grid plots, when we would like to show few maps each next to each other. Additional library to Google Map and special data some tools, additional tools, and geospatial data. So a lot of libraries, and hope that it will be possible for all of you install them. It's not always very easy because some libraries sometimes, especially on Unix, Linux, or Mac systems, require some additional libraries, but I hope that it could be possible for everybody. I set TEM for black and white TEM, which is appropriate for maps. And one additional remark about this line, because I have some question maybe. Okay.
Yeah, this is actually from me, whether we could get the code afterwards so our participants can. But
yeah, sure, I can give it to everybody, but how it possible to do it in Zoom?
Actually, I think on Zoom you have to click in chat box. You have a small icon of a file.
Okay, chat box, yeah. This one maybe. My computer. Okay, I try to do this.
Maybe you can share it now. So if it's possible, yeah, some of us, I think, will follow.
Sure.
Perfect.
Try to do this. Also, I can share with you the generated file from this Markdown. I also have this file. Okay. This is bigger, much bigger, because inside this file we have generated maps.
So yeah, if you feel that you would like to follow the lecture, just please look at the screen. If you would like to do in parallel some analysis, what's professor showing, you can feel free to do so. But you know, you can use the code afterwards to find some interesting stuff for you. So yeah,
sure.
Sure.
I think that you will you need to install a lot of libraries first.
Yeah, so you can start installing libraries and investigate the file later on. Okay, thank you.
Okay, welcome. And this line 33 line, because I prepared a lot of material a little earlier, I used the older version of projection and engine, which is used for transform data into spatial data. So here I use this line to revert backend engine in library, in this library SF to older version. Because in new version, they use Google projection system, and this is a little different. On maps, it's completely unimportant, but they decided to use it because it's more precise, they said. But in our situation, when we change this to true, we should rebuild spatial data. So I decided to use the older version. Okay, so I did this. Okay, how we can prepare very simple, very basic map. First, let's try to load data. We will use this function NE countries, scale medium, return class spatial file. So let's try to do this. Okay, let's see this file. Okay, what is it? We can observe maybe from the beginning, this is a collection of a lot of features and fields. We have multi-polygon. Multi-polygon is a file from to plot maps. So each polygon define one, in this situation, one country. So we can see some labels, countries, type, a lot of different features. And the most important for us could be geometry here. We have multi-polygon, so we have definition where this polygon is on the map. So we can start and plot it. Simple plot. ggplot function where data are here. This is our file, and geometry spatial file. This should give us basic map. Okay, we have map of where. Nothing special. We see the borders of countries. Very simple idea. Plot polygons. And the definition of polygons we could download from somewhere. Okay, let's try to add something. And we, at the first step, we try to add access names. And we also add the title of the plot and the number of countries we will see in subtitle. This will be length of word name. In word name, we see we have countries names. So let's see this simple map. Okay, so we have titles of access and additional title of the map. Okay, nothing special. Okay, now the countries are in gray color. It's very easy to change this. For example, here, fill light green, so we will fill shapes of countries by a light green color, and color of borders will be black, because color is the color of borders, and fill is a color of fill area. Okay, what we can do something different, maybe we would like to fill the countries using feature. And in this situation, the color of country will depend on some feature. And in this situation, I will use population. In our data, we have feature estimated population. We see that for most countries we have this information, and for few of them, for 3 of them, we don't have information, but we will try to use this information to add colors. So in this situation, I use the same geometry as before, and I use this feature to fill. And additionally, I change the scale to use scale friendly for color blind people. This is Viridis scale. I use option plasma, and additionally, I use transformation of feature on the scale, because we know that we have huge differences between population in countries. So a good idea is sometimes to change the differences, to reduce the differences by some transformation. Very popular transformation is square root or logarithm. In this situation, I use square root. We know that square root is increasing function. So when we change all values using such function, we reduce differences because this function is appropriate for this, and the order of numbers will stay the same. So let's see this. Okay, now we see that the most populated countries are China, India, and we added information to the plot. So in such way, we can add some colors to the map. A little later, I show you how to add additional information from other files, but now we use only Word data. So let's stop this in this moment. Now about projection. Projection is a method how we transform spherical data, because we know that Earth is spherical, and we plot such data onto plane. So this is the definition of this projection, and we have a lot of different projections, and it's possible to transform or plot our map in selected projection. In this situation, I change the projections to this. I'm not an expert in geography, but we have a lot of different, so this I show you how we can do this. Oh, in this situation, you see that this completely different projection. It's not a simple plane. It's like a sphere on the plane. So we can observe that the behavior on this plot is completely different than, for example, on this plot. And I plotted exactly the same data, And here I changed only the projection. Okay, so next very important topic is how to limit our data. So in this situation, I would like to plot only some part of the word. So I should give limits for X and Y. And in this situation, we don't have north, south, west, east, but we have positive and negative numbers. So 0 is, for example, in London, Greenwich, and on the left on this line we have negative, on the right of this line we have positive values. And let's see, for example, the plot of Mexican Gulf. Okay, so I limited. You see, we have west and here north. So I limited our map to this area. And now in few next maps, we'll try to add additional information to this small part of word. At the beginning, let's try to add very classic information like an arrow where the north is and the scale. We have ready-to-use function to do this. Annotation scale and annotation north arrow. Location, bottom left. Of course, we can use different location and with hint. This is annotation scale and this is arrow. Where this arrow is, which north true and similar options, and additionally this coordination extent, the same like in the previous exam. Okay, what is the difference? Do you see here? I have the difference. I have the north arrow and the scale. Okay, so now let's try to add some additional information to our plot. And at the beginning, we try to add some text where the countries are, for example, the name of countries. We try to add the names of countries. Of course, to do this, we need the points where this text will be. So the simplest idea is to try to find the center of the country. Not always it's very simple, because for some countries, like for example, Denmark, we know that Denmark, also the part of Denmark is Greenland. So in this situation, the center of these two areas will be a little not inside the Denmark. So this is not maybe the very universal method, but for most countries could be good enough. And we try to find centroid. Centroid is like a point inside the area, in the center of the area. What we are doing, so I prepare new data frame, and for each word, for each country, I add centroid. Let's see. What is it? This is this information about centroids. About centroids, here, this should be the last. So we added information about centroids, and now let's try to do this. And so we will add, you see, geometry text. This is information from points, and we use X point and Y points from this geometry, and label will be the name. Name is here somewhere. Name is the name of the country. Okay, let's try to do this. As you see, we have names of countries, Panama, Costa Rica, and similar, Cuba, Bahamas, and also we add information that here we have Gulf of Mexico. Yeah, but I added it by function annotate. I gave exact coordinates and the label Gulf of Mexico. Okay, so now let's plot the final map of this area. And let's try to explain lines. Okay, we start with, of course, the full map of word. We add geometry spatial file, anti-white. This will be the color. It's like a little blue. Geom text is about names of countries, name of Mexico Gulf, annotation scale, so we will add scale, arrow. This is extent to limits our area to also only Mexico Gulf. Labels, title, and additionally I change a little the behavior of grid lines on the plot. This will be dashed line and size half, and the color will be also gray. And additionally, I change the background of the panel. This will be Alice blue. Okay, you see, we have the title, we have the map, arrow, scale, names, and this is panel background is Alice blue. It's like a little blue. We have dashed grid lines, and I think this could be ready to use a map of this area. Maybe one information about colors. In R, we have a lot of defined colors. You can check all of them using function colors. And here you have the names of colors. We have 657 defined colors, which you can use by names. Or of course, it's possible also to use RGB system, but for most situations, this is a little simpler. It's a lot of colors, maybe a very short hint how to find colors, how to find columns. You can use function grep if you use Linux or Unix systems, Mac system, and terminal. You should know this function. We are looking for example, for blue color, and where, and here we have numbers, and we can change this parameter to see all colors which have blue in name. So this is very simple idea how we can try to find appropriate color. Of course, in internet you can find some web pages on which you can see the colors. Okay, so let's try to continue our journey to the map systems. Now we'll try to add additional points. So not only the names, but also we'll plot points. For example, like a city or something like this. So let's try and prepare file with coordinates. So I prepare simple file. We'll have two sides with coordinate longitude and latitude, and we must transform such prepared file into spatial data. You see, I change sides, coordinates, and this is projection system. Okay, we see that now I have projection here and geometry point, and I have 2 points. Do you see the difference? It's not a polygon, it's a point, definitely point. Okay, so I have 2 points, and now I can add them. So first I start with the map of world. I add sites here, where data are, sites, size 4, shape is the shape of the point, more in 1 minute, and fill dark red, and finally extent to limit to the Mexico Gulf. Okay, so I have 2 points. I have 2 points. Maybe few information about shapes. Point character. In R, we can use different numbers to define the shape of point. From 0 to 25, we have shapes, and from 0 to 14, we have points only with shape, without fill, so only borders of shapes. From 15 to 20, we have points only with fill, without border. And from 21 to 25, we have points with border and fill. So in this situation, we can define and the border of this point, and also the fill. Okay, so now we know how to add points. The moment we try to add text next to the points, but now let's try to add the borders of states. We know that here is Florida, but maybe we try to add additional information when the border between states is, and the names of states. Okay, so we need additional information about shapes of states. And we take this information from this function. We have map state. Yeah, here a lot of maybe I stop this because we have definition of points. This is definition of borders in states, and I transform this this file into spatial data. You see that we have information, 6 features, geometry, ID. You see, ID is the name of state. So also I add centroids to have the center of each state to add the name in this place. This is additional information. You see I have XY. Okay, and finally I change the name of state. Because here we have only small letters, I prefer the situation where the first letter will be capital letter and the remaining letters will be small letters. So I use library tools, and in this library we have function to title case, and I change the ID because ID in this file define the name of state. Let's see. Okay, now it looks correct. We have names of states in correct form. Okay, so now we are ready to add this information. Because to add text, we know how to do this. We use geometry text, the definition of points of where the names should be, we have in data states, and aesthetic. So the definition, what is it? X, X, Y, Y, and label, so that this is the text ID. Okay. Okay, so we see that we have Florida, Georgia, Alabama. Okay, it's not very bad, but maybe we a little change the places, and here I move a little all points a little down. This is states. I don't know the pronunciation, nudge, Y. So we down a little the names, and also for Florida, additionally, we change this to such values. So this is a little hand working, and this is, and I do the same once again. And now we see that we have a little different form, because now I used geometry label. You see the difference. Text is without this frame around the text. And here I used geometry label. So I added the frame around the name. And in this situation, you see that this state, South Carolina, now I see Georgia and Alabama are lower on this plot, and Florida is moved a little upper. Why? Here we see why. Okay. So what next? Now let's try to add counties. Let's try to add counties. Okay. Okay, we don't know, we don't have this information in our files now, because we have a definition of countries and we have the definition of states of United States of America. So we need additional information about shapes of counties. Okay, so we have this information here. We have county data set, And let's try to collect it. So we have counties. You see, we have a lot of information about counties. Alabama, Autauga, I don't have an idea how to read this. Baldwin, Barbour, and so on. And this is a multi-polygon. So we have definition of counties. We limit our counties into Florida. I use function subset counties. Grep, we use earlier grep to find colors. Grep L is logical grep. In this situation, I will obtain the information true or false. So I'm looking for the name Florida in counties ID. So ID is here. So this will subset counties, and I finally obtain only Florida counties because I grab L and subset. So for each county, I will have information this is from Florida or not. So I will subset only to Florida counties. Well, let's see, because maybe it's not true, but it's true. Florida, Alachua, Baker Bay, Bradford, and so on. So we have counties only for Florida. Okay, additional information, maybe I show you. This is area. This will be function st area, and I prepare something like this. You see, areas of counties is possible to calculate, and we will have here areas. Why I did this? Because I would like to add colors to my counties plot, and the color will depend on the area of the county. And here I do this. So we have, like always, map of world. We add information about counties. We fill counties using area. Transformation, square root, the colors for color-blinded people, and I limit our data to Florida. Okay, I have information for map of counties, and with colors depend on area. So we see that this county in yellow are the biggest counties, and more blue or violet is smaller. Okay, so now let's try to add to this map some cities. And maybe I show you two methods. One moment, I'm correct. Oh. Latitude, longitude. Okay, so we can do this by hand. So, for example, in this situation, I can prepare the file with cities, with definitions of cities. And here I did this. So I have data frame with state Florida, 5 cities, Miami, Tampa, Orlando, Jacksonville, and Sarasota. And I found information about longitude and latitude by hand. Okay, we can do this. But much better way is to try to collect this data using Google API. And here you have my API key. API key here. You should change this to your API key, and I add that information what you could select when you define your API in Google. So you should find in Google in your account on Google, and you could add API. You can use now my key, but in longer I think it could be problem with this API because I will change it. But now you can use. So we need this key. Okay. So I defined cities for which I would like to get coordinates. I prepared very simple function which we can use to collect coordinates of cities, get Google coordinate. This is function, this is the city name and Google API key, sorry, and address, this is paste, city, state, and I try to collect, and now I apply this function to the list of my city names. Okay, in coordinates, you see I have a list of coordinates, and now finally I have the list. Do you see? I have 5 cities, latitude, longitude, and point geometry. So I have coordinates. Okay, so now everything looks simple. I plot my map, geometry. Like always, I add information about counties, I add information about cities, and I will add information about the names of cities. Okay, you see, I have 5 cities here. REPL, so it's geometry like text, but the text not overlap the map. Także we have something like line indicating where the city is. Okay, so totally final map of Florida with all informations. So we have everything on this map. So we have names of states, counties, names of cities, some indicated points, arrow, scale. So we have everything about Florida, what was done before. And here we have title, 2 sites in Palm Beach County, Florida. Here, these red points are in Palm Beach. Okay, now let's do one additional map. Now we will try to add some additional information from other file. For example, when we have your data about something, and we would like to plot this data on the map. And let's try to do this. I add information about crimes, about assaults in US states in 1973, because we have data with such file in R, with such information in R. This is USARS. We have for each state, we have information about murder, assault, urban population, and rape. So of course we can use what we want, but I decided to use assault. This is the number of assaults per 100,000 of citizens. And in USA in 1973. 1973. How we can do this? First, we should join this information to our file, to our data with definition of states. So let's recall, we have states. Do you see? I have states. 1, 2, 3, 4 fields and 49 polygons. So 49 states. In this file, we don't have Alaska. In this file, we don't have Alaska. So we will plot the map without Alaska. Later, we will prepare plot with Alaska, but now without. So to this file, we should add additional columns with information about crimes. So how we can do this? I use function left join. So what I'm joining, I'm joining USA arrests, but maybe one additional hint. USA arrests is a data frame. We can check this. This is data frame. Data frame is very good, very popular format of data. But now much more modern data format is a table. This is not very big difference, but states, let's see the class states, data frame also. But in table, we don't have row names. See, here we have one column without name. It means that this column is row names. This is like meta information. This is similar to Excel file when you have the numbers of rows and letters for column names. And much better is to have this information in additional column. And I transform our data to table, and I give information that the row names should be in the column ID. Why ID? Because states contain the information about state names in the column ID. So to simplify joining, I use exactly the same name. Of course, it's possible to join using different column names, but it's much easier to use exactly the same name. So I transform data to table, removing row names and transforming these row names into column ID. And now I join. So let's see the result of this operation. Do you see? I have murder, assault, urban population rape joined to my spatial data. And now everything is simple. Now I use this data to plot, and I fill states using assault. I will use gradient from green to red. So green means low assault value and red high assault values, and title and extent. Let's see. Where is my map? Okay, do you see? So we can observe that in 1973, the most dangerous state would be maybe Florida. A lot of assault per 100,000 of citizens. So rather dangerous state. and North States looks much better using this characteristic. Of course, we can easily change, for example, rape, exactly the same, but only we change the crime characteristic. Oh, here California, and here is Nevada. I think Nevada looks very dangerous, considering rapes and murder, maybe. Murders also are very common in Florida and Georgia. Maybe about urban population, because we also have information about urban population. This is the percent of people living in cities. Okay, so it looks reasonable because California, a lot of people live in cities. North states are much more agricultural. Okay. Okay, I changed finally to assault. Okay. So this is about simple maps. And now let's try to do a few maps next to each other. To do this, first, let's prepare two maps. And the first map will be the map of the whole world. We know how to do it. Okay, this is the map of the whole world. And additionally, I use the colors of the region. Antarctica, Europe, Central Asia, and so on. This information we can find in this Word file. Additionally, I added a rectangle around the area of Mexico Gulf. So today we have. Okay, so I added a rectangle around the area of Mexico Gulf, and in the second plot will be this area. Let's see, this is our second plot. Okay, so I have the second, and now I try to combine them and place them on the one single map. So what I'm doing, okay, in the first solution, because I show you two solutions, I prepare such a plot using ggplot, of course, coordinate equal, and one moment. Okay. Now, what I'm doing, annotation custom, ggplot grob, because such object like ggulf is a grob, is a plot written in file. This is a grob, and where I'm start is from 0 to 1.5, and the same for y, and the second plot will start from 1.5 to 3, and from 0 to 1. So now I will have two plots next to each other. Okay, we have it. Of course, the scale is not perfect because maybe we should change this. This should be maybe bigger, the first one. For example, here I can change this. Maybe it will be better. Oh, for example, in such way. The second solution is much easier, but it's not so flexible, because here I can define how big will be each of the plots. And here I only define the grid and the relative widths. So in this situation, I will have one row, and the first plot on the left will be 3 times bigger than the second plot on the right. Okay, and this is the idea. Okay, so next very important idea are insets. Inset is one image inside the other, and in this situation, one map inside the other map. So in this situation, we will try to prepare the perfect map of USA. In this situation, we know that we have Alaska and Hawaii, which are outside the mainland. So we will try to prepare 3 different maps, and we will put Alaska and Hawaii on the map of the mainland USA. So let's prepare. Okay, we start with subset USA. In this USA, we will have information about country, about the states. Okay, we try to prepare the map. You see, this is the mainland area of USA. And I think that the best place to plot Alaska and Hawaii is here, bottom left area of this plot. And I need to prepare the plot. So I use the same file, but I limit to Alaska. This is Alaska. And the same for Hawaii. So we have Hawaii. Now we should calculate some kind of ratio. How big should be Alaska compared to the mainland? I do this here. And how? I use these coordinates, these values. How big it is. So I calculate one ratio for Alaska and second for Hawaii. And now I draw mainland and additional plot, draw plot Alaska with height ratio. And let's observe the final result. We have mainland, Alaska, and Hawaii. Okay, this is how to prepare insets. And next information is like a map with additional arrow when we would like to zoom some part of this map. Okay, so let's prepare information for our map. So we will have 2 sides. You know these sides because this is points. There are points from the previous exercise. These points, we have 2 points. And now we prepare Florida. You know the Florida map. Okay, we have Florida with 2 points. And now we add next to the Florida map 2 maps with zooming into these points. And the first, say, site A, annotation, panel border, everything looks great. Let's plot it. Okay, do you see? Zoom on it. The same with second point. And now we'll combine this. First, we prepare arrows, coordinates for arrows, because this is coordinates, and we draw. Draw plot Florida, side A, side B, two arrows. Okay, you see, this is the idea. It's similar to insets, but in this situation we don't add second map on the first map, but rather next to, and additional information we have with arrows. So we have general map and zoom to two selected places in this situation. Okay, this is about maps, and maybe a few additional words. For most maps which we would like to prepare in such way, you need information. I showed you how to find some information about countries, about USA. It's quite simple. About other countries, you should find files. This in most situations, this is so-called shape file. For example, for Poland, our statistical government unit GUS gives such information. It's possible to find this shape file for our województwa, for our powiaty, and similar. And when you find such information, you can plot in the same way. But first you can load shapefile from the okay. Okay, so now let's try to use Google Maps, because it's possible to use Google Maps to plot our own maps. And in my opinion, it's not hard. It could be even quite easy, and maybe even easier, because we don't need additional files with shapes. Of course, we need key. Google, sorry, not Apple, of course, the main enemy of Google. Google API key. Here you should register it. So from this point, we can use Google API to collect maps. And the simplest way to plot is QMap. Here you give the name of place and the level of zoom. QMap Poznań, for example. What is wrong with this? Maybe some problem with Google. Okay, and we collected map of Poznań from Google, directly from Google Map. Of course, we don't have possibility to zoom num and something like this, but we could add additional information. For example, here, I prepared a satellite map of Poznań with a bigger level of zoom. Oh, this is satellite map of some part of Poznań, mainly the city of the center of the city. Okay, this is very simple, I think, to use the pure Google map. But maybe let's try to add additional information like points. And I found very interesting data about crimes in Liverpool. Here you can download this data. I downloaded earlier, so it's not necessary for me. And one additional information, because I use Mac, I use method kernel here. If you use Windows, you should change this into internal. And in this situation, you will download file with this police information about crimes. When you would like to find original data, you could check this web address, and you should download such file in your working directory. How to check working directory? Get working directory. This is my working directory now, so I'm working at desktop, and in this place you will download this file. We have files about crimes. You see a lot of crimes reported by, falls within, longitude, latitude, so great. Where is it exactly? Some kind of code, name, crime type. Okay, crime type also we have, very interesting. Okay, and let's try to plot this. First, we need to add information about coordinate. So coordinate is longitude, latitude, and crime points. I transform points into spatial data. So crime points, we have coordinates, and now we can plot. I will prepare the map of Liverpool, zoom 12, map type hybrid. So this is a hybrid between satellite and route map. Where are data? Crimes, and latitude, longitude we can use. Okay, so we see the points where the crimes are. Of course, we can add additional information, for example, for what type of crime it is, or something like this. But in this situation, I use only, maybe it could be possible to shape. Yes, we have some limitation. It depends on the API. I don't remember now, but it's a lot of thousand for free account. When you buy, you should have a much higher limit of using Google API. Maybe I try to add the shape. I'm not sure about crimes. We have crimes, and here we have crime type. Let's check unique. Oh, it's not bad. So let's try to use crime type as a shape. I think this could be possible. Really hard. So let's change this a little. Maybe better will be color. because for me it's really hard to distinguish between shapes, so small shapes. Oh, so in this situation we can observe, of course, it's hard to distinguish colors also, but we have seen the drugs are red, green, bicycle theft, orange maybe, antisocial behavior. I don't know what is exactly, robbery, and so on, vehicle crime, violence and sexual offenses. Oh, maybe this could be interesting in my opinion. Let's see, maybe I show you something. Let's see where the violence and sexual offenses are. So let's filter our data, and crime type will be equal to violence and sexual offenses. And you see, this is the most, it looks like the most dangerous place looking at violence and sexual offenses. Of course, we can change this into, for example, bicycle theft, where our bicycle is not safe. Okay. Oh, here in the city center, I think. Of course, the main limitation is possibility to get data. I'm not sure where to find such data for example, Poznań. For Liverpool, I found in internet. Okay, this is the idea how to add the points, but also very interesting idea is to how to add some lines. For example, for bicycle lines or motorways. And I found information about motorways in the area of Manchester. And similar idea, you can download data here. And I have ready to use data on my desktop. So I read data. Okay, and in motorways, we have information, a lot of information, maybe I'll stop. We have information about lines, motorways. Okay, so let's try to plot. Okay, this is a plot of motorways in Manchester, but I don't have the map of Manchester. Now I should add these motorways to the map from Google. Let's try to do this. First, we should transform our data into spatial data. So SP transform, motorways, and of course, this is the projection system. I do this. Like you see, this could be quite time consuming sometimes. Our motorways now is spatial data. I do operation of fortifying, so fortify to speed up plotting the to plotting the map. Fortify, remove sometimes some details of the polygons, because sometimes some polygons are very, very detailed. In most maps, we don't need so detailed shapes, and we can simplify it. We do this using Fortify, and this, of course, speed up the calculations. And now let's try to add this information about motorway to the map of Manchester. Of course, we know what to do. Manchester, map type satellite, zoom level 9. Okay, and what now? We have geom path. Path is like a line, but with coordinates. longitude, latitude group. So each group will be for each motorway. Data are in data file, color blue, signs, and let's try to plot. You see, we have the map of Manchester with motorways. Yeah, this is the idea how to add lines to the plot. And the the last problem is to how to add the route to the Google map. How to add the route. And in this situation, I prepared the route from our Department of Political Sciences at Adam Mickiewicz University, next to my department, my faculty, to this address. This address is the address of Castorama or something like this. It's not very long. And so I need two addresses. This is the main idea. I need two addresses. Okay, so I have them. And now we have function to find the route. I think that all of us know the map, the Google map, so it's possible to find the route from one point to another. And exactly we are doing this using the function route, from, to, structure route, and mode walking. So by foot. Okay, let's see. Okay, we have route, meters, so the length of the route in kilometers, meters, and miles, seconds, minutes, hours, longitude, latitude. Great. Great. So we can try to add this route to our map. And now I need QMap. Let's see the area. This is the north part of Poznań. Here, somewhere here is our campus. And the Wilczak Street is somewhere here. Okay, so now we need to add the path. And the definition of path we have in this route data frame. The color of route will be in red, the size, where data and line and round. The end of line will be rounded. Okay, let's see. And do you see? I have route from Faculty of Political Sciences here to next to Decathlon shop. This is the Wilczak Street. And of course, we can add additional information. We can change zoom. We can add additional, for example, now next, for example, next route from this point to the other. We can change the color and so on, so on. So we can add, of course, more information. We can add a route. We can add points. We can add densities, polygons, areas. This is possible also to add other objects, not only what I showed. I think it's most of my presentation for today. I'll also prepare few exercises which you would like to solve. They're very similar to the problem which I discussed. So the first is to try to prepare the map of the Mediterranean basin. This is, of course, similar to the Gulf of Mexico. So we have a lot of countries around the Mediterranean Sea, and we can add them. We can add additional points, for example, or something like this. Second is preparing the map of Alaska, similar to the map of Florida. So with counties with main cities of Alaska, maybe with some names, something like this. And the third is try to prepare the map of Denmark and with Greenland as an inset. Maybe better even Greenland and the mainland of Denmark is as an inset, because we know Greenland is huge island and Denmark is rather smaller country. For Google, I didn't prepare an exercise because you should have data, additional data always. So if you would like to plot something, you should start from your own data, because as you see, it's very easy to download, to collect map from Google. But to add some information to this map, we need data about points, like here, where we have crimes, about motorways here, or about route, which route we would like to present. So always you should have additional information, about additional data, because simple map from Google, rather we don't need R to do this. We can use Google Maps. Okay, I think that's all for today. Maybe some questions, remarks, comments.
Thank you very much. And I can see that we have already a question from Wojciech. I have also a question.